later. Yeah, we're not going there right now. Right here. Look at your graph, please. The one that says force. Nicely done. Down at the bottom, I would like you to circle number 2. The number 2 spacer. Circle that. Circle number 2. Monitors, that is the one that I want your group to skip. So as the monitor, you need to make sure that your group skips that one when you get to it, okay? Did everybody circle number 2? Okay, circle number 2. Beautiful. And what do you do with number 2?
Skip it.
Skip it, okay. Am I forgetting anything else? Oh, come on. All right. Our job today is to gather evidence that proves or disproves, gather evidence that shows if distance affects force. We're gathering evidence to see if distance affects force. Are you set? Are you ready? Freeze. That was just to give me a minute to think. Okay. Getters. Back by Mrs. Castani is a balance with all the materials in it that you need. Carefully go get it, bring it back to your group. Careful. Careful. You could, but that's not fun. Who doesn't? Oh, okay. Yeah. Well, Kalika, if you guys can work it out, that'll work for this time, okay? We'll get you involved here. All righty. I didn't say what?
Garrett.
We didn't. Okay, ladies and gentlemen, what are you trying to find out?
How does magnetic distance affect magnetic force?
Remember to take turns. Get going.
You're doing my job. This comes okay, yeah.
Your monitor should be raising the getter. Are you the getter?
6, 7, 8, 9. Already? 9. Yeah, there's a spacer right there. Oh yeah. So we write one space. Wait. We write on here. One spacer. One spacer. 9. And we record that. So you write it right there. You don't put that.
Come on over here.
Oh yeah, you have to. We don't color it in. It's a line graph. Okay, next. It's my turn. Yeah. No, remember we're not doing two spacers. Oh yeah, we're not doing two spacers. We're doing 3 now.
Okay, it's barely sticking. Let's trade this out.
see about that. Please make room in the car. Oh God. Maybe we should put them under here. So there's 2 and there's 1. 3.
So we'll go ahead and just let
4. 9 spaces. 3 spaces. This is where I need a
Call money.
Okay. So okay, guys. Now we have to put washers in our sink. One at a time from rim to cup, like so. I'll put it. See. 1. That's the rim. That's the rim. 2. Put the rest.
Hey, one at a time.
One at a time.
Hold on, did you guys fill it up from here?
Yes. Yeah, that's
okay.
2. Then
Let's restart. Yeah.
Okay. Everybody puts one in. Everybody puts one in. I would go.
Each of you guys get 2. Paige get 2.
Okay. You get 2.
She got 2.
Okay, who go? Me first. 1. Your turn. 3. 4. 5. 6. 7. 8. 9.
Okay, get 2 more.
9, are we at 9?
Yeah. 9.
Hold on. 10. It takes 10 with the spacer.
Wait,
now we put it back. We put it back.
No, let's retry it to make sure our answer is clear.
I think it's clear.
Hold on.
Yeah, I think it's clear, guys.
No, let's retry to make sure it's definitely.
Just to make sure.
Yeah, just to make
I
sure.
think it's clear. Okay.
Here we please try it again. Here, each one gets 3.
No, each one gets 4. So we don't need to go 2 more.
How many do you have? Do you have 4? You have 4? Each of us do. Okay, each. You have 6.
I have 4.
Hold on. No.
4.
And then who wants one more?
I will.
Who wants this one?
I will.
No, you can't. You can only one person can only. Do you want it? Yeah, you can have 6.
Wait, what? Okay, me first. 1, 2.
Here we go.
5, 6, 7, 8, 9, 10.
10. That's 10. It's 10.
10. Wait.
So now monitor. Where do we mark
It's
that?
11. What? It's 11. Because I take one out. Take one out. And it stays. See what 11?
No, you gotta set it up like this. No, you gotta set it like this.
Okay.
Is it?
11.
No, take 2 out. Okay. Most likely.
It's 10 washers. 10. So
Okay.
we number it right here. Okay. No, like this. You see right here? Look at. You see right there? 10. Number of spacers. 1. Number of washers. 10. Okay, guys. Now.
Hold on, I think I know how to do this. Monitor, I think that we go like this. I think that we go up and where it puts 10, you just put a dot.
Okay.
That's what I want to do. But 1 all the way up to 10. Okay, long term, raise your hand.
Put the dots. You don't necessarily have to do the lines right now. Oftentimes you'll see the lines in there, but in this particular case, I think you're going to see something kind of interesting going on. So, how many did it take with zero washers? Did you guys even, or with zero spacers? Did you guys even try that?
We need to try zero spacers, guys. We need to try zero spacers. We need to try zero spacers. We forgot about that.
Does that mess up your data? It does?
No. Let's do it over again. Okay, let's do it with zero spacers.
Wait a minute, I have a question. Do you have to do it all over again?
No.
Oh, okay. I thought that's what you were saying.
We don't need to. Okay, now we have to go. Last couple of times, we barely let me do anything. This time,
Who is our monitor? Me. So are you making sure that we start back at zero every time?
yeah.
At that level? Okay.
Zero spacers. I love that. Okay, zero. Zero spacers.
Wait, where are you?
Are you all in the same spot? It looks to me like they're still working on something. Can you guys huddle up and see what they might need help with and make sure that they're with you? When we get to the end, you'll report it. Your group's fine. I have a question for you. Why did you move the scale over there?
We're taking turns. My bad.
Of course you are. Okay.
Yeah. Zero spacers. Zero spacers. Zero spacers equals. We haven't tried it yet. When? Five. Cinco. 7. 11. Don't know. 10. 11. 12. 13. 14. 15. 16. 17. 18. 19.
So what's your next step?
What's happening? Oh, here it is. Then we try this one more time. Excuse me, you're dragging my books to your side. They were on your side, my books. I don't know. What the heck? 3? I know why. Wait, that's backwards. That backwards can't hold that much. Yeah, that means weaker. 6. Finally solved. So, 1, 2, 3, 4, 5.
Dude, your brother Kevin, he
So what we're supposed to do is we're supposed to get 3 spacers and stick it in there, and then we're supposed to put washers in one by one and count them. And then after we're done with that, we're supposed to graph it.
Don't you think that's too much to break the force? I probably break the force with just 2 of them.
Yeah, but we don't know that.
We don't know. That's why we need to try it. That's
Yeah.
why we need to experiment it.
Yeah, and then you just graph it, and then you go on to 4. And then you put 4 spacers in there.
And let's see. Okay, so I'll start.
Okay.
Here,
Put it in at the top.
Yes, That's only 2.
No, that's 3.
Okay, go. Yeah, that's 1. 1. Really? 4. It takes 4. Wait, let's retry. Let's just make
I'll
sure.
hold it down so you can get the slushes up.
Okay.
Okay.
1. No, stop. 2. 3.
No, Diego, don't.
Really? 4. 5. 5. It takes 5.
5. Hold on, let's retest that. Let's retest it.
Because we got 2 different answers, so we need to retest. Yep, I agree with all
Nice job, guys. 3.
Now let's go 4. Maybe they won't even stick this time.
Now let's do the same
They won't
thing.
even stick, Aiden. With 4, they won't even stick.
Yes, they will.
Let's see.
Hold on, make sure they're leveled out. Like they're all together.
They are. Okay, yeah, you need 4. Okay, let's do it again. Let's see what's 4 now. We add 1 space. 1. 2. 3. Wait,
I don't want
let's
it.
retest. 3. Retest.
Is that right? Okay. Does that make sense?
Hold on.
How many did it take?
4. I forgot to mark that. What was it?
It was 3 and 4. I mean, I forgot to mark it here. 3 was 4.
Yeah, I just didn't mark it.
Wait.
What? No, this is 3 because Miss Garrett told us to skip 2.
Oh, yeah. So thank you, Hayden.
Okay, does everybody have like the right things on their paper? Let's go back to it. Yes, you do. One space. Okay, nice labels.
Are you the monitor?
I just helped
She's
her
the
out.
monitor.
You're the monitor.
So you're supposed to check everything. And they stick.
Hang on, she's just making sure that you're ready to go, right? Making sure that
Oh, you forgot to put washing. I know that.
So what are you guys finding so far?
How many? We're finding out how many washers it takes to break like the force of the magnets.
Right. I know what our goal is. Let me see if I can word that a little bit better. Is your data showing you anything interesting?
Yes.
Can you,
Yes. Yeah, it's showing us like
How much washers it takes to
break
break
the
one
force of the-
spacer
then we keep on adding
in between the washers.
Yeah, we keep on adding up the spacers until it can't hold it anymore. Until the force can't kills.
Yeah.
so you
I
guys have
agree.
done 1 and 3 so far?
Yes, and now we're on 4.
I'm going to come back and ask you guys that same question here in a little bit. Why don't you do 4, 5, and 6, okay?
Okay.
And I'll be back.
Okay. Okay, now let's do. How many are in there?
That's 4 in there.
4 is right there. Okay, now let's put the washers in. You can go first, Diego.
Thank you. 1,
You go.
2, 3. Hey! 4. Oh, 4.
4, let's do that
We
again.
need 4. 4 and 4. So we need to retry. Me first.
There.
1, 2, 3. Oh, 3.
Hey, let's do that again.
Yeah, because we had 2 different answers, right?
Yes.
This is the last answer. After this one.
What I want you to do is to repeat that and see what your group thinks, okay? So you're telling me what you are seeing going on here. But let's see if your group was agreeing.
The higher the number of spacers, the less washers it takes to break the force.
Agreed.
You agree with what?
That the
Let them tell. Let them say.
that the highest spacers you can break it easily because the force isn't working, it's getting bigger.
Like one spacer, two spacers, three spacers, and it gets bigger, and the weaker it is. When it gets bigger.
Like when you always drop it in, it starts bouncing and you don't know when it's going to break.
You don't know when it's going to break? Can you predict when it might break or when you're getting close? How do you know that?
It starts right here, and it drops like right there, and then it just goes down.
So, I asked you guys to skip number 2. Did you do that?
Yeah, we didn't do it. We predicted.
Oh, so you've just made a prediction. So, as a group, where do you think that the number of washers is going to be before it breaks the force?
6 for the 2.
5.
Yeah, for 2 washers.
6 right in the middle.
I'm still thinking about 5 or 6.
What did you think? Did you guys discuss that as a group?
We'll discuss it.
You'll discuss it? All right, that sounds like a good solution. So, you have a really good idea about what you think. I would like the whole group to either agree or disagree with that, and when I come back, I want you to be able to tell me why, and then we're going to test you here. Okay? All right, huddle up. Even get bumps out of your chair so that you can hear each other.
Okay. So, I think that, let's like, we should all like, we're trying to predict what two spacers, how many washers it takes to break the force. What do you think, Haley? What'd you predict for 2 spacers?
5 or 6.
What'd you predict? 6. What'd you predict?
I predict like 4, 3, and 5.
Okay. I don't want to do this.
Should we test it?
That would be you one testing. That would be cheating. You can't test something that you're predicting.
Yeah, but then you can try it. And see. Like scientists like try.
I think it's
Try
good.
it at exam.
It's right in the middle of 9 and 4. So 9. 1 washer and a half. Wait. 5? I think it's 6. Yeah. I already put 2 spaces right there. I changed my prediction. I think it's 6 because right in the middle of 4 is 9. And that makes sense.
I think I'm gonna change my prediction. Like I think it will be 3 and 7.
Because it's 5 spacers to make 3. And 6 spacers, 6 spacers to make 37. Yeah. That makes sense. So it's a good example. So, get this together. So,
Hey, crew, what's up? Okay, so when I left you, as a group, you were going to come up with a prediction about how many washers it would take to break the force at 2 spacers.
Like between
9 and 4.
yeah.
Which is like 56 or so.
So somewhere between 9 and 4?
Yeah.
Why do you think that?
Because the number 1 was 9, so and number 3 is 4, so 9 and 4. Between 9 and 4.
We think it's, yeah.
So you think it's between 9 and 4?
Yeah.
Somewhere around 6 or 7? Colton, can you tell me more about your thinking on that?
I think it would be 6 or 7 because there was no 6 or 7. It was just like 9, 4, 4, 3, 19, 3. Because it was one spacer, which was 9, 3 spacers, 4, 4 spacers was 4 somehow, 5 spacers was 3, 0 spacers was 19, and 6 was 3.
Interesting.
I think this theory is because that my idea, like what I said at the beginning, like I think that it will go to 6 or 7 because one washer would go like strong, and then 2 washers would go like in the middle, and then 3 would go like right there. So the more spacers, the less washers.
Yes. Because like right now we had 6 and we tried it out and we had 3, so
You had 6. You tried what out?
we tried how many washing would it take to take before.
Carly, what are you thinking?
I'm thinking 2 washers and 7. I mean 2 spacers and 7 washers.
2 spacers, so in between there, and 7 washers. And why did you guess 7 washers?
Because 2 is like a small number, and I think the magnetic
You can help her, Corey, with words.
I think it would make sense to. I think it would make sense because 9, 4, and 2 is a low number, and the magnetic force is strong, as we all know. And
The force is strong, as we all know. Yeah. Okay. Colton, could you give 2 spacers? I think this will.
there's already 2 under here.
Oh no! Would you give Carly 2 spacers? No, not the ones that are on there, honey. Just the ones that are in front of you. So Carly, when you have 2 spacers, is the force very strong or not through 2 spacers?
It's strong. Because
Pretty strong.
very skinny right here. So
Uh-huh.
I would think it would go through.
Okay. Is it going to be stronger or weaker with 1 spacer?
Stronger.
Stronger. Okay. I would like you to test your theory now. See how close you came with your prediction. Okay? Go. Who's?
We just have to put the washers in, and then we see which one. There's
already
2 under here.
We put 7 in there.
No, we just put them in and see how many there are. There's already 1.
1, 2, 3, 4, 5, 6, 7.
Correct. We were 100%. This is Garrett. We were right.
5 or 6.
So you need to double check your work. Is that why won't that work?
I'm going to put this smiley face on.
Why won't that work?
Because you don't measure how much the distance is.
The height. You can measure the height.
You could get a ruler and measure this, and then that would be like your specific thing, your specific measurement. But if you're like up here,
if you're like up here and like all over around like that, you can't really measure. You can't really measure.
And then you have to grab another one, and then you forgot where you were.
Is that going to give you the same results as when Paige drops it in from down here? No. Do you remember what that's called?
A variable.
Exactly. You aren't holding your variable constant, right? So everybody needs to do it from the rim. Alrighty? So are we need to probably empty the cup and start it again?
Yes.
Okay, so you guys are working on 0, correct?
Yes.
You're working on 0, correct?
Yeah. Okay,
All
let's
right.
put them in.
Get it done.
1, 5, 6, 8, 9, 18.
We need to retest that, guys. Really? Yeah, because we got 2 different answers.
No, I don't need it. The last one. Nobody double check. Guys.
I think that we need to double. You gotta choose.
Okay, guys, we need to recheck it. I agree with Hayden because we need to recheck it to see if we get the right answer.
What if it actually was 17 and the last person just put it in lightly?
Yeah. Fine. Hey, I only have one.
Yeah,
And I only have one. I only have one too. 1, 2, 3, 4, 5, 6, 7, 8, 10. 2 down.
17. That was our answer 2 times.
So it's
Are we working?
prediction was 100% correct.
So what was your prediction?
My prediction was 6. I got
6
5.
what? 6 tomatoes?
2 out of 3 tries, it was 6 washers. So we tried it 1 tries, it was 5.
Okay, so is there a place where you're telling her how your prediction and your data connect? Is there a page where we're supposed to work on that together?
Can you put on the stop clock?
Why, that's what I'm thinking. Is that what she said? Okay. Okay.
She just didn't test it out.
Okay.
Yeah, so, but it didn't work. Wait, how many was that? I think that was 5. Yeah, 6. Where are we count? Guys, I grouped them. Okay, Okay. I think you said but dude, tsunami. Can you repeat that again? Huh? Can you repeat that again? Actually, according to my research, I think we have to do this picture. To have our final results. I think we have to recheck these. Okay. I'm going to maybe the basic. So we have to recheck it?
So 0 spaces is the first one.
Tsunami wave. 4, 5, 6, 7, 8, 9. plays with him.
Yeah, but dude,
I want to play with them yesterday.
I'm gonna have you,
okay, so we need to do it again. Hey, I did it.
Okay.
Oh,
You did it?
okay. 19 to what?
19. So.
Okay.
18. I'm kind of nervous now.
We are.
Okay, so.
I know.
So now we have to do this again and figure out something else. We need to play. Let's do this one.
maybe? Yes. Go
So,
ahead.
okay.
Okay, yeah.
Okay, how many more? Okay, now let's try.
Oh, good.
Let's try 3 washes this time.
Where is
Okay.
two?
Don't let them connecting. Okay, now we're trying 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
I'll be right back.
14, 15, 16, 17, 18, 19, 20, 21, 22. Alright, 22. So we're gonna break it because so it won't break when there's 3, but there's actually 5. Still won't break when there's 20. Now it broke. Alright, now let's try and see if it actually breaks. Yeah, it broke. So it took 24. So it took 24 watches to break. Yes, it did. So let's see if we can add any more. Some chips. Yeah, let's try. Okay, let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's all. Get your. You go get us some more washers.
It's a little bit different.
So what we're going to do is we're going to put 2 washes in there, maybe 3, I don't know. 2 washes in there and all the chips in there and see if it will make a difference.
Pair up with somebody here. Get your
We're waiting. Got more.
So let's start it over
Okay, so you've got
before we experience.
now, yes. Now you need to
Everything tried
do 2.
it.
Okay? Oh my goodness, you guys are just waiting.
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes!
I'm going to give you 2 minutes to finish up your current stop. Okay? So come to a good stopping point in 2 minutes, please. Go.
20, 21,
21. New score. 21.
21.
You're at your conclusion?
Yeah.
First of all, you guys tell me, how close did you come on your prediction?
Got 5 right.
You were right on?
Yeah. Yeah, because we said all the same. I think the distance will affect because it would make it weaker. All of us said that. I said I think this affects it by making it weaker.
Okay. So now our science idea, the conclusion is, prediction was right. Now, what do you know about distance and the force of your magnets, your magnetic force?
Distance will make it like the distance. If you make it really close, you get more more washes in. And if you make it really light, you get like half. Like if you got 10 for like dropping it really low, you probably get 5.
So if your distance is small, your washers
have more.
you have more washers. So
had 0, and then you had 11, then you had 3.
Okay. So what if the distance is far away? What if it's a greater distance?
It would be like,
How many washers does it take?
probably 1. Yeah.
Okay, so not very many. So if the distance is greater, the washers are fewer, less. And if the distance is less, the washers
Have more.
have more. You guys just said your conclusion. So as soon as you tell what your group predicted, you can tell me what the science idea that you just came up with about the distance and the number of washers.
So I'm going to that is
30 seconds, crew.
my group's prediction was right because we all thought it was weaker. Yeah, my group said that. Our group said that. Is it ours? No, mine. My group prediction was right because we predicted all our predictions were right. Let's put my prediction was. How do you spell that? This is what I know. I know my group said that if the distance is farther, it would be weaker. Why should we be far apart? I don't know why. So I said our group prediction was with mine. My group said that if the distance is farther, it would be weaker. What we can same because. What? What did you do that for? What? I said our group
Okay, ladies and gentlemen,
was the same
your washers in your cup.
people said it would be weaker.
All your washers in the cup. All your spacers in the cup. Your post in a cup. And show me time, please. Oh, I hope you remember what that means. In 1 and 2. Man, you guys are marvelous. If you would just put your spacers, your post, and your washers in the cups and have the getter take it back to Mrs. Castani, we'll talk about your results. Alrighty? 30 seconds to get that done. Go.
Where do you put it?
Papers are right in front of you right now. You're good. Getters, thank you for getting that done. Get it. If you are still writing on your paper, now's a good time. You've got like 30 seconds to kind of complete your ideas. Now, class, we don't have enough time. Look at the clock. It's 3:20 today. Do you know what that means?
Oh, we have to go home.
It means I have to come back and talk to you about our conclusions on another day. Does that surprise you?
No.
Are we ever going to get done with this unit?
Yeah.
Where's a good place to keep these papers? Get it there, and then eyes on Mrs. Castani, please.
We don't have a science folder. We don't have a science folder. It's science. No? Sorry. No, look at what I said. Our group prediction was the same because we all said it would be weaker if the spacers.
Okay, class.
Yes.
Your desks are cleaned off, your eyes are on me. This is good. Still waiting for a couple of people.
Okay, I'm going to put this away. And I'll look.
Before you guys get a 5 each. Nice job being ready to go.
Mrs. Castani, I am really excited for roster.